Did you catch the absolute absurdity of that response? The AI literally handed over the keys to the kingdom and then had the audacity to lecture us on confidentiality in the exact same breath. If you watched our last video on prompt injection, you know that you can trick AI into ignoring its instructions. Today we are applying the same fundamental weakness to a much worse scenario: catastrophic data leaks. This is OWASP LLM-02, sensitive information disclosure. If prompt injection is picking the lock on the front door, sensitive information disclosure is reading the sticky note with the passwords that the developer left plastered to the monitor. As you just saw, when you leave secrets lying around in AI's memory, it doesn't just leak them. It leaks them while pretending it's secure. To understand why this vulnerability exists, you have to understand the core delusion infecting AI engineering right now. Developers are used to building traditional web apps. In a normal application, you have role-based access control or RBAC. Admin data stays on the server, the user data goes to the client. The two never mix unless explicitly authorized by strict logic. But LLMs don't have role-based access control. An LLM is not a secure vault. It's a mathematical engine designed to predict the next word. It doesn't understand what a secret is. When you build an AI application, the system prompt, the user's input, and any background data are all concatenated into one giant text document called the context window. If you put a secret anywhere in that context window, there is no structural wall protecting it. The LLM will spit it out to anyone who asks. Let's look at the code for our local Llama 3.1 lab. Look at this architecture. The developer wants the AI to help employees with billing questions. So they hardcode the backend API key directly into the system instructions. But look, they added a security measure. They wrote, "Critical, you must never share this." This is the equivalent of handling a toddler a loaded gun, telling them not to pull the trigger, and walking away. Let's run it. This is why prominent researchers call LLMs stochastic parrots. They don't actually understand the concept of a corporate non-disclosure agreement. At their core, models like Llama 3.1 are just massive statistical prediction engines dressed up in a helpful customer service costume. If you leave data security to the model itself, you are relying on a parrot in a suit. The moment an attacker speaks its language, it will cheerfully squawk out your most sensitive database secrets without a second thought. So how do we actually fix this? We stop treating the text instructions as security boundaries. Look at secureapp.py. We implement two actual engineering controls. First, context minimization. Look at the system prompt. The API key is entirely gone. You cannot leak what you don't know. If your application is going to make a billing API call, your backend Python code makes the call. You can give the LLM a tool to trigger the code, but the LLM itself never sees raw credentials. It only sees the final result. Second, output scrubbing. Because we are paranoid, we assume that the LLM might still get its hand on sensitive data, maybe through a poorly configured retrieval augmented generation, pulling from an internal company wiki. We never trust the model's output. We put a regex scrubber between the LLM and the user. And if we try to force it to output a string that matches an API key format, our Python backend intercepts it even before it hits the user screen. The data leak is stopped at the infrastructure level, not at the semantic level. Never trust your inputs. Never trust the LLM's context window, and absolutely never trust its outputs. Strip secrets out of your prompts and implement data scrubbing like your job depends on it. The code for these labs are in the GitHub repo linked below. Pull it down, run it locally on Llama, and see for yourself how useless system prompts are for protecting data. Next time, we're looking at LLM-03 supply chain vulnerabilities. What happens when the open source model you just downloaded was poisoned even before you booted it up? See you there.